All right, today we're going to do a proper technical breakdown of Nanobot. We're going to pop the hood and really dig into the architecture, because there's something pretty special going on here with how lean this thing is.
And yeah, this is the number that gets your attention right away. Roughly 4,000 lines of code. In a world where AI agents can be massive, sprawling enterprise projects, this is just tiny. It's kind of hard to believe at first.
And just to be clear, we're talking about the core agent. This isn't some simple little script. It's a whole system with memory. It can connect to multiple platforms, and it can actually use system tools. That's what makes this number so wild. So that leads us to the big question, right? The whole reason we're doing this deep dive. How is that even possible? What kind of architectural decisions did they make to build something so small, yet so powerful? Well, that's exactly what we're about to find out. Okay, so let's start with the most basic thing an agent does. Reacting to a message. We're going to follow a user's message from start to finish to see the main components in action. So at a high level, the flow is just beautifully simple. You've got an input, say from Telegram, that comes in through a channel. It gets dropped onto a central queue, which they call the bus. Then the agent itself picks it up, thinks about it, maybe uses a tool, and then sends the response right back out the way it came. It's a really clean separation of concerns from the get-go. Digging into step one, this channels module is a really key piece of the puzzle. You can think of it like a universal translator. It doesn't matter if a message comes from Slack or email or Telegram, it takes that message and turns it into one standard format. This is so important because it means the main agent doesn't have to care at all where the message came from. It's totally agnostic. Okay, so once the message gets to the agent, that's when the magic happens. The agent is the brain. It figures out the context, it talks to the LLM, and, this is really cool, it can use tools. And we're talking powerful stuff, like direct access to the shell, the file system, even tmux. Now, before you panic about security, it's all sandboxed. The restrict to workspace flag makes sure the agent can't just go rogue and mess up your system. It's power, but with guardrails. So that's how the agent reacts. But from an engineering standpoint, this is where Nanobot gets really interesting. It can be proactive. It doesn't have to just sit there and wait for you to message it. It can kick off tasks all by itself. And the difference is pretty simple, right? Reactive is a conversation. You ask a question, it gives you an answer. Proactive is more like a true assistant. It just does things based on time or events, like generating a report every morning or checking on a server's health every hour. No import needed from you. The first piece of this proactive engine is the heartbeat service. Honestly, the best way to think about this is like an internal alarm clock for the agent. It's just a simple, regular ping that wakes the agent up and asks, hey, you got anything you need to be doing right now? And the way this works is just elegantly simple. I love this. At some interval you set, say every 30 minutes, the service literally just reads a markdown file called heartbeat.md. If it finds any text in there like, summarize yesterday's logs, it just feeds that text to the agent as if it were a prompt from a user. It's such a beautifully simple solution for what can be a complex problem. Now, if the heartbeat is the simple alarm clock, the cron service is the full-blown mission control scheduler. This is for when you need more complex, precisely timed, reoccurring jobs. This thing uses standard cron expressions, so you get all that power and flexibility to schedule tasks for, every single Tuesday at 3:15 in the morning. And the most important part is that a cron job can trigger any action the agent can perform. It can run a shell script, send a message, execute a custom skill. This is where the serious automation potential lies. So now we've got two completely different ways for the agent to get a task. It can come reactively from a user, or it can come proactively from a scheduler. How does the system handle both without becoming a tangled mess? Well, the answer lies in the absolute core of Nanobot's architecture. And it's called the bus module. This is the central nervous system. Every single thing flows through here. It's an event-driven backbone that completely decouples all the different parts of the system from each other. And this is where it all just clicks. A message from a user on Slack, it goes onto the bus. A scheduled task from the cron service, onto the bus. That little wake-up call from the heartbeat, you guessed it, onto the bus. The agent itself has no idea where any of it came from. It just pulls the next task off the bus and gets to work. This total decoupling is the secret. It's how you keep the code so clean and so small. This quote from their documentation just nails it. This is the big aha moment.
The whole reason a 4,000-line agent can be so powerful is because of this incredibly elegant, event-driven design. It's just a textbook example of great software architecture.
So let's bring it all home. How does this beautiful architecture get us back to that shocking number we started with? Just 4,000 lines of code. It's because every module has one job, and it does that one job really well. The channels module only worries about communication. The bus only worries about routing events. The agent only worries about thinking. This means there's almost no duplicated code. Every single piece is lean, focused, and independent. And the results of that design are things you can actually feel. Because it's small, it's fast. Because it's so well architected, it's a dream for researchers or anyone who wants to tinker with it. And because it's modular, adding new tools or new channels is actually pretty straightforward. It's extensibility done right. Which kind of leaves us with this one big question. In an industry that seems to think bigger is always better, Nanobot really challenges that idea. It makes you wonder, maybe the future of powerful personal AI isn't about these giant, complex systems. Maybe it's about small, arrogant, and proactive agents, just like this one.